I'm afraid he's gonna fall.
I know.
Is it going?
Yeah.
Okay. We forgot to start this at the beginning of class. So
You're awkward.
you're a little
awkward
behind.
angle.
We're talking about concavity. Concave up, slopes are getting bigger. Concave down, slopes are getting smaller, if this was a function. Now we're going to talk about if it's a derivative.
Wait, so the slope's getting bigger, it's concave up, and if it's getting smaller, it's concave down?
Yes.
Now we'll go back to what it really is. And let's make a chart.
Can you see?
Can you see right here?
Yeah.
Can you see my finger?
Yeah.
Okay.
You can see about an inch of the wire.
Where are, you can look at this and probably determine where key points are where things change.
-2, 1, and 4.
-2,
Actually, probably not number
0.
4.
0,
Oh, yeah,
1,
3.
1, 3, and 4. Right? That's where things, whether it's the slope or whether it's the second derivative, something happens here, something happens, right? Here, 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 and here. Right?
Yeah.
Yeah.
Yep.
So we're going to set up a chart with all of these intervals. So we're going to say from -4, I'm going to write that as intervals, to -2, from -2
To 0.
0,
0 to 1.
0 to 1,
1 to 3. And 3 to 4.
okay, 1, 2, 3, 4, 5. And then, in order to help us here, the things that we're going to determine about each of these intervals, we're going to talk about the sign of the derivative.
You can barely see that.
Can you see that?
You see n of derivative
It's
of
a sine of prime of x. And then we'll have, is the derivative increasing or decreasing? That says derivative increasing or decreasing. Because these two things are going to help us determine everything else. So let's go through and fill it in. What is, you can do it. What is the sign of the derivative? This interval, this interval, this interval, this interval, this interval.
Wait, what does that one say?
Increasing or decreasing? Is the derivative increasing or is it decreasing?
-4 to -2.
Positive or negative? Because you can be,
So when you're looking at the derivative, positive is above 0, negative is below 0.
yep. So from -4 to -2, it's
Positive.
Positive.
from -2 to 0, it's still positive. From 0 to 1,
Positive.
still positive.
From
1 to 3 is negative, and
No,
then
all we're looking at is if it's above 0 or below. This is our derivative. So the sign, it's positive, it's positive, it's positive, it's negative and
negative
negative.
and negative.
Now we're going to look for, is it increasing or decreasing? It's not the same thing. Is this from -4 to -2, what's happening?
It's decreasing.
Decrease.
Decreasing, it's going down. Even though the sign of it is positive, it's decreasing.
Confusing because what you just did with the numbers, how it's like getting bigger, I would think it would be increasing.
Well, that was, remember we were thinking it was
The
the original.
original.
Oh, yeah, okay.
Now this is the slope, this is the graph of the derivative.
So now this just
It's
shows.
positive, the derivative is positive, but it's getting smaller. So it's decreasing,
And then it'd be increasing.
And then increasing.
And then decreasing.
Decreasing.
And then decreasing.
Decreasing
And
and
then
increasing.
okay.
Okay, that makes sense. It's like legit.
Now we can use this to answer all of our questions.
So you just basically put it into sections by.
Yeah, by where key things are happening. back to the concave up question. Doesn't concave up happen when your slope is getting bigger? Isn't this a graph of the slopes?
So it would be concave
So
up.
it's just where this thing is increasing.
So Tanya was right, -2, 0.
So -2 to 0.
And 3 to 4.
Isn't it? So it's concave up from -2 to
I
0.
said 1 to 4, so I was wrong.
At first you said
Folks at
-2,
home,
didn't you?
over on this side of the board,
Oh.
we're making a list of where it's
He's like,
concave up.
nope, someone was right.
So concave up when it's
And anywhere else?
3 to 4.
3 to 4.
3 to 4.
So then it'd be concave down the rest of them?
Yeah, let's do concave down. Concave down would be the rest, yeah. Because the slope is getting smaller, and the slope is getting smaller, and the slope is getting smaller. Let's do where are the local extrema?
Ooh, I don't remember what all that. Wouldn't that be your zeros?
Before we can even answer that, we gotta think, where do they happen?
When your slope equals
When
0.
it's 0.
When the slope changes.
When the slope is 0.
Hills and valleys. That's always the answer.
Hills and valleys. So when the slope changes sign, right? Because it can't just be when the slope is 0. Because remember, you could have
Because it can
stuff-
still go positive.
you
and
could
it
have,
won't
like if
change.
this is my original graph, you could have slope hit 0 and then still go positive. Remember, because like on your sign chart, if that's your critical point, whatever that is, and you have plus and then plus, that's not a max.
So it's when the
when
slope
the-
changes from negative, positive, positive,
Yeah,
negative.
So when the slope changes sign, that's one way. Or when the slope doesn't exist, that's not going to happen here because this is continuous.
Oh, so it would be like there's a
The
gap or
derivative
like an
doesn't
open
exist.
circle.
Yeah, which I don't even think you'll ever see that. Or endpoints, right?
Which those
Which
are
they do have
endpoints.
as-
This has endpoints.
Yeah.
So let's go with first where the slope
4.
changes sign, right?
So there's only one.
Didn't you say it was at like?
Where does this change sign?
One.
1. The slope changes from positive to negative, doesn't it?
Yeah.
Oh, I was
Yeah.
thinking it's original still.
No, this is the derivative. So where's our first place?
So you have
X
a,
equals.
1.
it's a max.
Oh yeah, okay, that was gonna be my next question. Is it a max or a min?
It's a max. Because it's going positive then negative.
Yep.
It's on top.
Isn't the slope here positive?
Yeah.
Remember, you're not looking at the actual slope of this line, you're looking at the value of the y. So it goes from positive to negative, that's gonna be a max.
I just looked at that, the positive, negative go up, down, yeah. And then your endpoints.
Yeah, so here, we have an endpoint, and then what's the slope to the right of that?
No, positive.
So if we have an endpoint and the slope to the right of it is positive, what is
Local
it?
max.
It's a min.
Wait, say that again?
Oh, positive, yeah. Down, right?
You have an endpoint, and the slope to the right of it is positive. So the original graph would go up. Even though this is decreasing, that's okay. That just means it's concave down. So its slope is going up, but the slopes are getting smaller. See, eventually we're going to take all this information, we're going to draw the original. Not today.
So then you have a,
And then this endpoint, let's see, whose turn is it? Katie! Is that endpoint going to be a max? or min? Why? The original would be the endpoint. To the left of that, would my original be going up or would it be going down? Well, that's confusing because to the left, the slope is negative, right? So it would be coming down like that. Is that what you meant? Down is from left to right. I did it backwards when I just said that. So you're right, it would be a min.
so when you say left and right, is that because of the side of the graph it's on? Like the graph is obviously going to be to its left since it's an endpoint.
Yeah.
Okay. I just didn't know if yours, that's why you're saying that. So what about increasing and decreasing? Does that say it's concave up and concave down?
This way.
It's positive, positive,
What?
positive.
Increasing and decreasing, is that the
What
same?
increasing? Like the original? Or
Well,
So from 1 to 4
no,
decreases
on this
from
one.
-4 to 1.
we asked where the original is increasing.
So what, if they ask, they won't ask for the, yeah, they asked last yesterday, a derivative.
That was the original.
We were just wondering where is the original increasing? The original increases when the slope is
You
positive.
know what I'm saying on the derivative, what if it asked if where it was increasing?
Where is the derivative increasing?
Well, last night on 23 and 24, those were both derivative graphs, and it asked increasing and decreasing. On 23 and 24?
No, it says on which the function f, the original, is increasing or decreasing.
Oh, so you had to go from back.
I mean, because we just answered where the derivative is increasing or decreasing just by looking at the picture right there. You know those.
Okay.
And I think there's one more thing we need to answer. What's the last one? Oh, points of inflection. This is
Is that where the slope changes sign? What's that?
points of inflection. What's point of inflection?
The slope, nope. Yeah, where the slope changes. No, not the slope.
Or change sign, I don't know.
Changes from concave up to concave down,
Yeah.
Yeah.
or
Well,
down to up.
so it wouldn't be the
So
slope, it would be
1?
when it stops increasing and starts decreasing.
Yes.
Well, yeah, how do you say that in words that make sense?
I can't even remember what you just said.
So would
When
negative
it
2 be
stops
1?
increasing and starts decreasing.
Yeah.
Would negative 2 be 1?
So would negative 2 be 1? Isn't it decreasing? This, remember, this is slopes.
And it stops.
The slope is decreasing, now the slope is increasing. Isn't that a point of inflection?
Yeah.
Yeah.
There you go.
So then another one.
So what if it was increasing and then it
then-
decreases?
That's okay, same thing.
So then it was 0.
And then 3.
0.
And that's, and then 3.
3. 0 and 3.
Well, you could just look on the increasing, decreasing when it changes from one to the other.
down here. And changes, negative 2,
Changes,
0,
it stays the same, then changes.
3.
Okay, guys.
So that's just all, how do you go back from looking at the derivative graph?
Draw the original? Let's do it. Why not?
Well, like,
Wasn't what I was going to do today,
Slope is
but
positive, I think it's.
how do you figure out the
less
things on
positive.
the normal by looking at the derivative? That's what,
the things,
Yeah,
the
like-
y values,
like what we did last night for our homework.
you have to draw possible, you can't draw the original unless you know one of the points it goes through. But we can come close. We can draw the shape of it.
So like, yeah, we did all those off the derivative, but in our homework it had us either look at the original and do it off the derivative, or look at the derivative and do it off the original. You get what I'm saying?
No.
She gets
Like if you had the graph of the derivative, your questions were asking for your original function.
Yeah.
Yeah.
So now I'm
We just
saying,
did that.
no, yeah, but that's the thing is
So
we
you
did off the
made that
derivative, but now
graph.
we're gonna have to do that on the original off the derivative, which we didn't do.
I don't see that's the part
You
I
get
don't-
what I'm saying,
You-
right?
I know what you're
did
saying.
those, But you made that graph, like you made it f of x at the time when we did them. Do you remember when you changed it?
This?
Yeah,
No, I didn't.
you're like, let's pretend this is f of x.
No, we were talking about concavity and what it was. That's when we.
Okay, yeah,
determined
but still, we
that
did all
it's-
those things, right, for the derivative, right? Like, everything we just did was off of a derivative graph.
Yes.
Okay, looking at the derivative graph.
Yes.
Well, in our homework, we do everything that, but off of the original graph.
Oh, you want to do that right now?
No, that's what I'm saying, how do you do that from looking at the original?
It's kind of the same ideas.
No,
No.
that's why we all screwed up our homework.
Yeah.
Yeah.
I
didn't
have no
understand.
clue what the original was.
Like, you can give me a derivative graph and I can do that, but give me original graph, I could not do that for the derivative.
Okay, let's do it.
You get that now?
So we're going to say this is the original. Right? And we're going to answer these same questions?
For the derivative. So you'd be like,
For
Like, look right here, like, okay, so you gave us a derivative graph, right? And it says to answer questions of the function, the original.
The original is increasing, yeah.
Yeah, okay,
Okay.
so then how do we answer, or the other way, these weren't the original, we answered the derivative.
Oh, the original says where is the derivative positive, negative, and 0?
Yeah.
Okay, we can do that.
We
Well, I
all,
don't think he understands.
we all did, but you didn't.
It's because your words don't make sense.
That's
They make
not
sense for
right.
everybody else.
I didn't even know.
So that's the original, and you want to know when is the derivative 0 increasing or decreasing?
Yeah.
Like just like the homework?
Or how do you answer all those questions we just found out off of the original?
Okay, let me do that too. So
I hate derivatives.
what was the question? When is f increasing? Look at it.
Wait, 2 to 0.
Negative 2 to 0
And 3 to 4.
and 3 to 4. That was easy.
No, but the
The
question
question would be, when is f prime of x?
is,
When it asks like the derivative.
Oh,
No, this was the derivative.
That's not what that's. You just asked two different questions.
No,
that's why
that's
I'm
what
getting
I'm saying.
confused. You asked when is f increasing. You asked when is f prime.
No,
she
That's a
meant-
different
no, no, no.
question.
that meant like, look
We'll do them all.
No, yes, that's what the, like, okay, we're
Read the
looking at the
question in the book.
original, but it asks questions about the derivative.
And then when we look at the derivative, it
We're-
asks questions about the original.
Yes, see? You
read
should
the
try our
book.
whole
I was
book.
getting angry and writing so fast.
Because you guys
We're gonna answer all of these freaking questions.
Hey, at least we're trying.
we can't even speak.
There. We're gonna answer all those freaking things
Yeah.
right now.
Yeah.
Double prime, oh my
Yes,
gosh.
it is.
Okay, so f of x equals
Yeah.
0 at negative.
That's the original. We're gonna answer when is it equal to 0, when is it positive, when is it negative.
At
When is it
negative
greater
2
than
and
0,
1 and
positive,
4.
negative. That's the second. Yeah. Negative 2,
1.
1 and 4. Yep. X equals negative 2, 1 and 4.
Okay, when it
That was
is in-
easy.
Greater
see.
than 0.
Jay, you want to take this one? It's your turn.
Wait, what does it ask?
Don't
Was
think
it
too hard.
increasing or was it concave up?
It's asking when is f of x greater than 0? Huh? Jeanette, when is this is the original. When is it bigger than 0? You don't get the question?
No.
Pedro, do you understand?
Oh, 1, yeah, and then that's all.
The x values of where it's greater than 0.
Negative 4.
Negative 2 and negative 2 to 1.
4 to 2.
Above the x line.
Bigger than 0.
Negative 2.
Well,
Negative
He's
2.
getting feisty now.
Zero.
No, okay.
Up to 0.
No,
And
no,
0.
yeah, it's this way.
Okay.
It's always this way.
No.
And negative 2 to 1.
Yeah.
Yes.
So when is it less than 0?
1 to 4.
1 to 4.
Okay, now you think about the derivative, that's going to throw me off.
Well, now you just
What are you thinking when you're thinking derivative?
Slope.
Slopes. When
So
is
that
the
slope is negative.
So slope 0 at negative 2, 0, and 3.
Okay,
The
you're
slope is
done.
0.
I'm dumb?
You're done.
No.
It's not your turn. She just told us where the slopes were 0. Did it make sense? Isn't the slope 0 right here?
Isn't it the slope 0 at the same thing?
Right here?
Doesn't
Right there.
Yeah, I got those.
So x equals negative 2, 0, and 3.
that's all?
Carolina, you're up.
Yeah, you go
Is there
to
any place else where the slope is
this
0?
right here and you just line it up.
No, I thought.
See, if you're looking at the
If you get
original,
lost questions,
it's actually
he's
easier.
mad.
Why do you think on the other one you put like 1.2?
I didn't know how to answer.
Okay, sorry.
Carolina, when is the slope greater than 0?
From negative 2 to 0.
Negative 2 to 0.
And
And
3 to 4.
3 to 4?
yes.
Right, wait, that's only
So this
because
one's
the way the
increasing
lines are
then?
going are going positive, right? Like the slope way.
Yeah, it's like increasing. It is that. This does say increasing because that means slope is greater than 0 equals increasing. It is the same thing. So
Why is this so
so
hard?
guess what this one is?
Decreasing. Oh my gosh, can we get that for a point on our test?
Because the slope is negative and it's going to be going down. So you're done. Alondra, what's your? When is this thing?
From negative 4 to 2.
And
Negative 2.
And from 1 to 3. Yeah, it's -2. I lied.
what?
Negative 4 to negative 2.
Oh yeah, -2. And then
And then, I don't know. It's either 0 to 3 or 1 to 3, but,
well,
When does it stop?
you're looking at slope, right? You're not looking at the actual values of the y on the y-axis.
so it'd be from 1 to 3,
What's the slope right here?
negative.
Okay.
So it's,
Okay.
Huh?
so it's from 0.5.
Oh, what's the slope right
He was
here?
saying it's between.
Isn't that still negative? Still negative. Still
0 to 3.
It is 0. It starts going negative right there. So from 0 to what? 3?
3.
Pedro, you get to decide. Ooh, these you don't necessarily want to do them in order.
We haven't even went over that,
Second derivative?
like with this sort of stuff.
Oh, looking at the original?
Yeah.
Okay.
Well, isn't that just the slopes of the slope?
Huh?
Right?
Yeah, 'cause you have x squared, it's gonna end up to 2x, it's gonna end up to 2, so it's gonna be a horizontal line.
Oh, you're doing the function.
No, but I'm saying that's how I look at a double derivative.
Let's go with this one first. F double prime is greater than 0. What's that mean in other words?
That is
The slope of the slope is
When
bigger
is the
than
slope
0.
positive? No, that's not right.
The slope of the slope. So it's when the slope is getting. Isn't this just concave up?
Dude, I don't like that concave crap.
Well, you better start liking
That's
it.
an alliteration.
This is concave up, meaning the slope
It's just increasing.
is increasing.
Negative.
The slope is getting bigger. So this is the thing where the slope is getting bigger. It could be going down. You could have a negative slope and still be concave up.
So is that from like -4 to
So from -4, isn't the slope still getting bigger and bigger and bigger?
So from negative 4 to like 1. Negative 1.
Negative 4 to like
Negative
point-
1.
negative
I would say
0.5.
that right there.
Yeah, see, I don't get
Where's
that.
concave up?
That's when the slope is getting
That's when we
bigger.
said
That's
that
the one we just did. Like if you rewind, the one we just did where the slopes were getting bigger and bigger and bigger and bigger and bigger. Pretty soon the slopes are stopping to get bigger and now they're going to start getting smaller.
So then from
And then at
1
1 they start to
to
get bigger?
4
And
again.
then I would say somewhere around in here they're going to start getting big.
So probably
Somewhere in
2.
here, somewhere in there,
1.5.
it's going to change again. So
1.5
like this one would be
to like
-4 to -1. The slopes are getting smaller from -1 to whatever. And then now they're getting bigger again, aren't they?
Yeah.
Yeah.
So this one would be like your whatever to.
1.5 to 4.
So where does this equal 0?
At that point. No, I don't know.
Yes.
Because they're points of inflection.
It goes from bigger to smaller there.
So
Negative
1, negative
and
1,
1.5.
negative 1.5.
Check YouTube when you're ready for your homework.
Please don't make it a longer
I'll do
video.
it 7th period. Try to make it short. Because I don't have anything planned. 'Cause this wasn't what I planned on doing.
Turn off.
Yeah.